Hello, welcome back to Oracle DBA tutorial. In this tutorial, we are going to discuss about durability characteristics of a transaction. All right. So let's try to take an example, and then how this what's meant by durability. Let's say our transaction is insert into table T, say value is 1, and then I'm going to do insert into another table T1. Let's say values is equal to 2, and then I'm doing a commit. So this is a very simple step, SQL statement transaction. And then so let's try to understand what is, and then when we say that commit, and after Oracle skips back saying that commit completed, we expect that this value of T, not in table T, there will be a value 1, and in table T1 there will be a value 2 that is permanently there. That is durable. That is what is called a durability of a transaction. So whatever happened after that point to the machine, we can always going to go back and recover this value 1 and 2 in table T and T1 respectively. And how that works, let's basically recap of our Oracle architecture concepts a little bit. That we discussed that Oracle architecture, in Oracle architecture class, that a server consists of two things. One is your instance, and in instance we have this thing called SGA, or system global area, and then we have a bunch of files. Those are consist of database, which is data file. Say this is the data file, and then we might have a redo log file and so on. So redo file. So this, in this data file, actually this value 1 and 2 stored, and then in the SGA we have two pools, important pools, which is called buffer, DB buffer, and then I have another thing is called redo buffer. So there are some other pools are there, but for this concept, what I'm trying to explain you, I just in order to make this diagram simple, I just consider that I have this buffer pool and redo buffer, I have data file and a redo. Then I have two background processes. One is LGWR, which is going to write from the log writer to the redo log file, and then I have another process is called DB writer, which is going to write from the database buffer to the database. So whenever this step we are doing insert into T values 1, so the first thing is going to happen is that this buffer is become dirty, and then this thing is written here. And at the same time, in the redo buffer, we are going to store what is the information to redo this thing again. Okay, and after that we are going to do the second statement, insert into T1 value 2. So therefore what I'm going to do here is I'm going to have make another block dirty saying that this value is 2 here, and also same time I'm going to write in the redo enough information that we can redo this statement again. So this is how the scenario, and after that whenever we do a commit, immediately log writer is going to write these two dirty buffer to the redo buffer, to the online redo log file. So that means so all these things are being written here, and then I can clean this thing, or I can clean this thing, that okay, this is empty. But as you know, DB writer is a lazy writer. It's not going to write right away. He's going to write on his own time. But at this point, once we say that commit is completed, and once we store the buffer from the redo buffer to the online redo log file, then we are safe. We are safe in the main that if now for whatever reason this instant crashes or this SGA is wiped out, then we can always go back to the online redo log file, and then we can recreate these two statement and apply in the data files. So like what supposed to be written from here to here, if it is not there, if for whatever reason this is wiped out, then we can always go back to the redo log file, online redo log file, and then recreate these changes. That means commit, it's like, that means the database in a consistent state. That means whatever 1 and 2 from here I can reconstruct and write it to the data files. So next time I'm going to select start from T, it give me a result 1. From T1 is going to give me result 2. So that is how this commit works. And the moment Oracle says that commit completes, that means it is durable. Durable means whatever, if for whatever reason this SGA crashes out, still we can find the data, not a problem. However, whenever you're going to write this thing, all the write operations are generally expensive. So anything that whenever you're going to access the disks is expensive. It means it takes some time. It takes more time than something being changed in the buffer. So to get away with this, Oracle with release 10G R2. Okay. So from database 10G release 2, Oracle introduced a new clause to commit, which is called commit write. So what commit write will give? If you give a clause called no wait, in that case Oracle is going to, like, say for example in this, when you say this commit, right, immediately you get an answer that commit completes. Immediately you get answer and commit completes. But in that case the log writer may not have written to the redo log file, but the log writer is told go on and write this dirty buffers whatever is available here, try to write to the redo log file. But in that case it has not yet written. Okay, so if you give that kind of things, a commit write no wait, and imagine a scenario like this. Say you give commit write no wait, and then Oracle immediately gives back is that commits complete. Commit completes before actually it is, and then log writer is in the process of writing, but it has not completed the writing, right? It's not complete all the buffers whatever is available here is not yet transferred to the online redo log file. And that time, let's say the instance wiped out. If the instance wiped out, then you may be in a scenario where you have not written to the data files, and even you have not completely written the redo buffer to the online redo. So in that case there may be some data may be missing. So that is that durability, whatever we are saying, that whenever say commit, if database says commit completes, it does not necessarily guarantee you under certain condition in 10G release 2 that your data will be durable. Then why Oracle introduces this new feature? Oracle introduces this new feature to make sure that whenever you are doing a commit, you're not going to wait for that things to come back. Okay, so it's something like a synchronous, not like an asynchronous way that okay you wait for them and then come back. If your application is very much dependent on a kind of consistent model, like when say that commit, I must commit, and then what you can do, you can use in Oracle 10G release 2 commit write wait, or this commit write wait is a default behavior of 10G. That means every commit should wait so that redo buffer is going to be written to the online redo log file, and then the commit will take place. So this is the one thing that you need to look, like even if you have a durability, if even Oracle guarantees durability, but in this very particular case with Oracle 10G release 2 and above, you might be into a problem where you may not be durable, it may not be permanent, even it says that it committed.